Stephanie, can you tell us the 3 steps of finding our vertical asymptotes? Alright, so yesterday we've been practicing, or we've just been practicing for the past couple of weeks, x-intercept. Class, that means to make y to 0. There is no y variable. There it is. So y equals x squared minus 9 over x squared plus 4x minus 21. Now, you could find your x value without factoring. You can do that, but it might be faster if you just factored. Remember, the numerator can be written as x squared plus 0x minus 9. So when you factor that, what do you get? What do you get, guys? X what? Plus 3, x minus 3. Raise your hand if you got that. In the denominator, this is your x box, right? 2 numbers that multiply be negative 21, but add to be 4. 7 and negative 3. Okay. So we're going to make my y variable 0. Make a 0 fraction by putting in 0 over 1. Okay. When you cross multiply this and this, 0 times anything is what? 0. So I have 0 equals 1 times, or I don't have to write the 1, x plus 3, x minus 3. Here you should identify that this is the 0 product rule. That means one of these expressions has to be equal to 0, so make them equal to 0. And then you will get x equals negative 3 and x equals positive 3. So my coordinates for my x-intercept are negative 3, 0, and 3, 0. Raise your hand if you got that. Good. So I'm just doing review. This wasn't even yesterday's lesson. Alright, let's get the y-intercept. Y-intercept we need to make x0. And I'm going to, again, you can here at this point, you can use the factored form, or you can just use the original rational function. So I'm just going to use the factored one. 0 plus 3, 0 minus 3, all over 0 plus 7 over 0 minus 3. And that will get us 3 times negative 3. Negative 9. 7 times negative 3. Negative 21. Negative times negative is a positive. The factors of 9 are 3 and 3. 21 is 3 and 7. So my 3's cancel, and you're left with 3 sevenths. My order pair is 0 and 3 sevenths. Raise your hand if you got that. Good. Okay, so we asked you to find your x and y intercepts. We're just finding pieces of the puzzle. Okay. Now the vertical asymptote aspect of those 3 steps will apply. So vertical asymptotes. Okay, watch this part. When I factor, let me write out the factored form. So important. Put your pencils down and just watch. You're going to lose it if you're trying to copy. Factor and cancel. The parts that you're canceling here, this becomes your removable. Just watch for 40 seconds. X minus 3 equals 0. We have a removable at 3. What are the coordinates of this removable whole? you could actually take this coordinate x and just put it in here. 3 plus 3 is 6. 3 plus 7 is 10. I get 6 over 10, or 3/5. The vertical asymptote, we set the denominator equal to 0. So I use a really obvious color. And notice how I'm not using the canceled. So x plus 7 is not equal to 0. Subtract 7, x is not equal to negative 7. This is my vertical asymptote. These in different colors, so when we graph our rational function, you can see this. Alright, now for graphing this, my straight edge and right now all we know is about vertical asymptotes. We're going to learn today about horizontal, but let's just get these colors in. So I'm going to graph my x-intercepts, -3, 0. And 3, 0. I have my y-intercept of 0 and 3/7, so it's not a whole, almost a half, so between 0 and 1. Something right there. My vertical asymptote, -7. Okay, I don't like this one. I'll tell you why. At -7 is really far over here. 3, 4, 5, 6, 7. And that vertical asymptote is now going to break your graph, right? This is your discontinuity here. It's an infinite. So that means you're going to have 1, 2 parts of your graph. Pay attention. If you think about what your graphing calculator is going to spit out, it's going to spit out a picture that looks kind of just in here. So you'll kind of get a graphing failure because you won't see the second part of the graph over here. So we have to be careful. We can do that removable later once we get a graph. Okay. So yesterday we talked about using table of values to get some idea what's happening here. So this is -7. So let's get like 3 points over here. -10, -9, -8. And then we can get a couple of points over here. -6, -5, -4, and this looks kind of weird over here, so I'll just continue. -2, -1. Punch into our calculator. Remember, when you put into your calculator, you can do the original rational function, or you can do the factored form. Does not matter. I'll just do the original. X squared minus 9 divided by x squared plus 4x minus 21. Now I do want to note, if you do put in the factored form, right here, you're going to need an extra set of parentheses. So in my red pen here, if you were putting in the factored form, make sure you're putting an extra set of parentheses. Okay, so we're going to go to my table, so make sure you're pressing second table set or second window. You can start at any number. You want the change of the table in ones, and then I have autos here. You could have ask for the independent if you wanted to. Now I'm going to go to table, so that's second graph. You can just scroll up and down. I'm going to find -10 and then write down those numbers. 2.33, -9 is 3, -8 is 5, -7 is an error. We already learned that that is my vertical asymptote. -6 is -3, negative 1, negative 0.33, negative 2 is 0.2, and 0.333. Okay, let's fill those in now. Everyone say pencil. Use a pencil, sketch your graph just in case you make a mistake. So negative 10, 8, 9, 10, I'm at 2.33. Negative 9 is at 3. And negative 8 is 5. 4, 5. So it looks like our graph is doing something like this. And this will actually flatten out, and we'll learn that today about horizontals. Alright, I did these. Let's do negative 6, negative 3, negative 5, negative 1, negative 4, negative 0.333, negative 2 becomes positive 0.2, negative 1 gives me 0.33. So it looks like my graph is doing a U-turn. You see it? Something like this is happening. And it looks like if you put your pencil this way, everyone say slant asymptote. There is a slant asymptote, but we're not going to learn about that in this class. And then now let's take a look. Zoom 6. Something happened here. Do you see it? I think my graph is also having a horizontal asymptote here. So something's wrong there. Should have gone more this way. Erase. And I finally figured out another calculator tool. If you go to Window, so I accidentally went for my graph, so you press Window, and where it says X res, I don't know what that means, you can put two numbers there, 1 or 2. If I put 2, it actually takes off the, no it didn't. Never mind. I thought it was going to take off the vertical asymptote. I don't know what happened. I'm sad. Hopefully you're not sad. And we just graphed the rational function by hand. Awesome. I know what happened here. So in the original problem, once you factor, let's just say you set both of those not equal to 0. It's not a vertical asymptote, okay? But class, can you have x equals 3? We'll put it in there. 3 minus 3 equals 0. 0 times anything is 0 in the denominator is bad, undefined. So what we forgot is the orange one, which is my removable. So on my graph, there's actually an open circle here. What's right there, class? And that basically says once you get to that little circle, it's undefined. So it is a hole, they call it. And that's why we can't have, if you actually put in this number 3, it doesn't work. So that's not there.